Okay, in this video we are going to do derivatives of logs with polynomials involved, alright? So here are two formulas that we're going to use in this video. The derivative of log of absolute value of x, actually really just log of x, but the derivative of ln x is equal to 1 over x, and the power rule, in other words, the derivative of x to a power is equal to the power times x to the power minus 1. Alright, so these are things that by now you are familiar with. Alright, so let's just jump right into it. Here's an example. Let's take the derivative of ln of 3x to the fourth plus 3x to the fourth. So how does the first one go? Well, you see this thing inside the ln, it's not exactly x, so we got to be a little careful. If you watched a previous video, you'll know that you have to use properties of logs to do this, and at the end there was some shortcut, but let's just do it the long way again, alright? Life can't be that simple. All right, so ln, derivative of ln of 3x to the fourth power, how's that going to go? Well, first, let's split everything up. ln 3 x to the fourth is equal to ln of 3 plus ln of x to the fourth. But we know that this can be written as ln 3 plus 4 times ln x. Okay, nothing to do with 3x to the fourth, so let's just write that down again, 3x to the fourth plus 3x to the fourth. And we wanted to take the derivative of it, so let's do that. Take the derivative of this entire thing, all right? And look at this, the first thing is ln 3, that's just a number, so the derivative of that is 0. The next thing, 4 ln x, well, the derivative of that is going to be 4 times 1 over x. And the last thing, 3x to the fourth, that's just going to be power rule, so 12x cubed. And so the final answer is 4 over x plus 12x cubed. Okay, so there you go. Notice that we had 3x to the fourth and then ln of that same thing. You see, if you take ln of anything, you take the derivative of it, it's going to be nowhere close to the power rule. In this case, it was just 4 over x. So you got to be, it's pretty easy to tell if you did something wrong when you take a derivative of a log. It's going to be something very different from what you see in the power rule or any of the other rules. Okay, so let's go to another example. Let's do derivative of x squared minus ln of square root of x. So first part is simple. That's just 2x by the power rule. And the second part, well, ln of square root of x. Let's go over to the side here and just rewrite it. Ln square root of x is equal to ln to the ln of x to the 1/2. Okay, so ln of x to the 1/2, that's equal to, well, I could bring the exponent to the front, so there you go, 1/2 times ln x. Great, so all I need to do is take the derivative of that thing. That's just going to be 1/2 times 1 over x. And so the final answer is, if you want to just be a little bit neater about it, there you go, 2x minus 1 over 2x. Okay, let's do another example. This one looks super complicated, right? X squared e to the 5x, oh god. So what are we going to do? So ln of the product. So don't think too complicated now. We don't know product rule, we don't know quotient rule or chain rule or any of these fancy rules. Just a bunch of formulas right now. We do know the power rule though. That's going to help. So how are we going to do this? So ln of x squared times e to the 5x. Again, we take advantage of some log rules. We can break up the product inside and write it as a sum, just like we did in that first example. And now we use some more properties of log. So the exponent inside can come out to the front. So we have 2 times ln x. And then here we get 5x times ln e. Now things are looking really bright for us. This is equal to 1, ln e. And so you have 2 ln x plus 5x. Okay, so you see I haven't even taken the derivative yet. I was just simplifying this part. So let's go ahead and take the derivative. Okay, so at each step, you know, we're taking the derivative. I didn't really have to write that 3 times. Anyway, so you take the derivative of 2 times ln x plus 5x, and you get 2 times 1 over x plus 5. From the power rule on the right side, the part on the right, and using the formula for log for the part on the left. And that, well, before I say final answer, let me rewrite it so it looks a little bit neater. And there is the final answer. Check. Okay, and that is all. Just remember, you know, it's much easier to distinguish when you're using when you have to use the formula for logs, obviously because there will be a log there, but at the same time, it's easy to check if you're getting that answer. It's somehow easier to check if you're getting that answer right or wrong, or at least feel that you're getting it right or wrong, simply because when you look at the derivative for a log, you don't get a log back, okay? And in everything else, for example, when you take the derivative of a polynomial, you get a polynomial back. Okay, great. And when you take the derivative of an exponential function, you get an exponential function back. Great. Okay, but with log, you actually get 1 over x. So that's easy to sort of check if you're getting that's a sort of easy little intuitive fact that you could use to see if you're doing these correctly or not.